We are the BRG Physics Learning Device. My name is Wade Titterton.
I'm Kent Sullivan.
I'm Joseph Repa.
Okay, so a bit of a recap from last time, the design phase one. We looked at the purpose and opportunities of our BRG. We also determined our primary customers and customer needs. And from those needs, we were able to determine our target specifications, and we also performed a preliminary economic analysis. Now in this presentation, the design phase two, we'll be going over the intellectual property, which I'll jump to here in a minute, but we'll also be going over project decomposition, concept generation and selection, as well as investment perspective. So with intellectual property, what we did was we looked at 5 patents, and we tried to determine new ideas, as well as look at ways to solve some of the problems we may be having with our design. So we looked at a pinball machine, a machine for the drawing of lottery balls, flexible toy car racing track, marble track toy, as well as a Werner index position sensor. And the major takeaways from this are, first, how are we going to internally power our BRG? That's a big problem that we have to confront, because the ball is going to come into our system and we have to get it through the course by somehow adding energy to it. For example, how this was able to help us, looking at a pinball machine, it has all sorts of components like bumpers, plungers, all sorts of things like that that could easily add energy to the system, especially with a plunger, which comprises of a string. You'd pull it back and it could launch the ball forward. Now the second thing that looking at all this prior art, all these other inventions did for us, was it told us what kind of features we might want to include in our BRG. For example, from the marble toy track as well as the race car track, we have an idea that we want this custom fit flexible track that's going to allow us a variety of different designs to include, as well as just limit the error that's involved. But overall, intellectual property, it's helped us to form new ideas as well as solve some of the issues we might be having. Now looking at product decomposition, here you'll see we have our black box. Basically what this does is it takes our project and we take a step back and we try to simplify everything, look at it from an easy perspective. And you'll see here we have the BRG, and basically we have what potentially could be inputted and what potentially could be outputted. Now in the next slide, we'll look at the refinement, the black box refinement, and you can see what specific sub-problems the BRG comprises of. So the way this breaks down is the ball will enter, it'll have to go through all 3 obstacle courses, and if it travels through all 3, the ball will come out. Now all of this is sort of interdependent, but the user, the student, they'll make adjustments, they'll make observations, make calculations, make adjustments to the track, and those in turn will affect all 3 obstacles. Then you also have energy. Energy's coming in. We want to store that energy internally, then convert it to the different components. Now, if all of these work together, the ball should go through, and what should come out is the ball, and of course, student understanding of the different physics concepts that they applied to the course.
In order for the BRG team to kind of flesh out possible designs for the project, we decided to create a concept combination chart. This allowed us to mix and match different ideas that were created during the brainstorming process and draw what final designs might look like. In order to do concept screening, we created a concept screening matrix. What this allowed us to do is look at the drawings that we had created from the previous slide and then rate them on whether or not they met specific criteria. From this matrix, we took the top 3 ranking designs and then we put them in ranking in our concept scoring matrix. The concept scoring matrix gave us a little bit more of a refined approach where we could weight the criteria and specifications and also rank how well a specific design met a certain criteria. From this process, we deduced that design number 4 met our and our customers' criteria best. In order to do concept testing, we needed to make sure we were able to reach our target market. So we figured out that the best way to do that would be to do it through email surveys. The reason we thought this was best was because teachers are busy, and we thought email surveys would be a little bit more flexible with their schedule. In order to make sure that the data we picked up was accurate, we asked the screening question, are you a professor or teacher or student in a physics 11th or 12th grade class? To this, we got a response of yes 100% of the time, and from the data we were able to collect from the survey, we were able to estimate the quantity of products that we believe we'd be able to sell in a year, that number being 1,266.
So for our economic analysis on how we wanted to receive our money for our investor, we thought it would be best to break it up into 12 payments in an annuity over the 12 quarters of the 3-year-long project. And so this is more beneficial because then we get the money just as we need it to pay off our fixed $10,000 overhead cost and operating cost. And this way, when you take the present value of all these annuities added up, instead of it being $30,000 at the beginning, it would only be $23,000 roughly, which saves us money and allows us to maximize our profits for our investor. So we have an MAR of 16%, which is more appealing than a minimum of 12, and we'll think that it would make our product more economically pleasing. At the end of all this, we would have to pay a lump sum of $36,000 and around $600. And to attain this, we need to sell roughly 400 units per year because we make a profit of $30 per unit sold, which is well within the 1,266 units that we could possibly sell each year. And so as a summary for the DP2, we took a look at some prior art and gauged what has previously been done and what we can infringe on, but also helped us think about some new concepts and possible opportunities for us to improve our design and really maximize the potential of our product. Then we also analyzed how the product needs to perform and the breakdown of that, and which designs best meet our needs and what our customer wants. And from what our customer wants, we had a survey sent out which gauged customer interest in buying the product, and also took a look at what designs people thought were the best and would be the best for our product going forward. And then with our economic plan, we came up with a solution to best get money from our investors and output a reasonable and appropriate MIR for them to take home. So thank you.